Let's say I had the system of equations that look like this. X plus y plus z equals 4. Also, I have 2x plus y minus z equals 1. Okay? And then lastly, I have 2x minus 3y plus z equals 1. Okay? Well, first of all, notice that you have 3 equations and 3 unknowns, so that makes it more difficult. But in the end, what I want you to realize is it's not too bad. What you need to do is you need to employ the techniques that we've used, but you have to do it twice. You have to use this pair of equations to eliminate a variable, and then use this pair of equations to eliminate a different variable, and then you'll be able to see as we go through it how that helps you solve the problem. Okay, but you need to basically do the addition method on one pair and an addition method on another pair, and then move forward. So let's do that. Okay. What I like to do is draw curly braces to remind myself what I'm working with. I'm going to work with this pair of equations now. Okay. Notice that if I just add these two equations together, the z's are going to cancel immediately for me, which I love. Anytime you see something that's going to cancel, you want to work with that. So let's do that. If I add up the left, I'm going to have x plus y plus z, which is just this right here, plus this, which is just 2x plus y minus z. All I've done is add this right here, equals 4 plus 1. Okay, well right away you know the z and the negative z are just going to disappear. Okay, so I can just make that clear by drawing a line through both of those, because neither one of those are going to stick around because they just cancel out. But the x, when you add it with the 2x, is going to give you 3x. Let's keep working in blue here so that we can keep track of things. You're going to have 3x. Okay? The y and the y over here is just going to give you 2y. And then that's going to leave you with 5 on the right. Okay? So, notice we've taken these two equations, which had 3 variables, and we've done our magic and we've reduced it to an equation still in 2 variables. Okay? So, that's good. Okay? The next thing I want to do is I want to work with these two equations. Okay? I'm going to work with those down here. Again, I notice if I add these equations, the z and the negative z are going to cancel. And I like that, so I'm going to press with that. So what I'm going to have is, on this side, in fact, let's change colors so that we know that we're doing something a little different here. We're going to have 2x plus y minus z plus, and then I'm going to add this in, 2x minus 3y plus z equals 1 plus 1. Like this. 2x plus y minus z, this. Okay, and then you add this, 2x minus 3y plus z, okay, equals this, okay? Again, I notice right away that the negative z here cancels with the positive z there. And that's exactly what I was trying to do, so that's good. The 2x plus the 2x is going to give you 4x here. The y minus the 3y is going to give you a negative 2y there. Y minus 3y gives you negative 2y here. Equals 1 plus 1 is 2. Now look here. I've used these two equations to arrive and to simplify to this, and I've used these two equations to arrive and simplify at this. Okay? Now I can use whatever technique I want to be able to solve this system of equations. I've kind of used this mess to arrive at this. Okay? I immediately notice if I were to add these two things together, the 2y and the negative 2y would cancel. And so, because of that, that is exactly what I'm going to want to do. Let's work with this. I'm going to use a different color because we're moving on to doing something different. 3x plus 2y plus 4x minus 2y, which is just this, plus 4x minus 2y, okay, equals 5 plus 2, like this, okay? And again, we've already said it before, but just to make it clear, the 2y is going to cancel with the negative 2y because they subtract the 0. But the 3x plus the 4x is 7x equals 7. Well, this starts to look very nice because x is just equal to 1. Now, we've actually made some headway and we've found that x is equal to 1. How, might you ask, would we actually continue on to find the rest of the solution? Well, the way you do that is you take what you know and you go back and you plug it back in to one of these equations that you've derived here. Okay, so we want to remember this. This is one of the answers. Okay, and we're going to plug the 1 back into here. 4 times 1, because 4 times x, minus 2y equals 2. This is just 4. And so what you're going to have is negative 2y equals 2 over here minus 4 on that side. And that is just going to equal negative 2. So I'm going to put my double arrow here, which means that when I finally solve for y here, I'm just going to divide both sides here by negative 2. So negative 2 divided by negative 2 is just 1. So y is equal to 1. And that is something important. Okay? Now you might ask, and maybe you're getting the hang of it now, how do I find z? Well, I know what x is, I know what y is. If I take it and I plug it back into one of these equations, I can find z. And I'm going to pick the simplest equation up here. Okay? I'm going to draw a little barrier here. I'm going to use this one. X is equal to 1, so I'm going to put 1 plus y, which is equal to 1. I'm going to put 1 here, plus z equals 4. 1 plus 1 is 2, plus z is equal to 4. Subtract the 2 to solve for z. Z equals 2. All right, so I have x is equal to 1, y is equal to 1, z is equal to 2, and if I wanted to write that in terms of a point, okay, I would have 1, comma, 1, comma, 2. And this, this is x, this is y, and this is z. And really, this is really not that different. I mean, it's just 3 equations and 3 unknowns. So it's a more complicated system, whereas in the other system of linear equations with x and y, it was something 2-dimensional. This is 3-dimensional. So as the line may have been talking about distance and time, this might be distance, time, and pressure or something. It could be any variables that you're using in your system. And these different equations might describe the behavior of something you're trying to study, and this solution is the point at which all of them are valid. So it's a little bit more complicated, but in the big picture, what you do is you use 2 of the equations to derive a simpler equation. You use the other 2 equations to derive kind of a simpler equation, and then you use the 2 equations that you derived, and you go ahead and use the techniques that we talked about earlier, the addition technique or the substitution if you wanted to, and you go on and you start finding variables. Once you start finding variables, it becomes simple. You plug them in, and you find the other variables. And you can easily see how problems like this can take up, a whole page. And you notice that, I drew a lot of arrows, and I draw a lot I take things very slowly. I don't really skip any steps. Okay, let's go ahead and solve another one of these systems, just to get more practice with what you need to do. 2x plus 2y plus 3z equals 10. 3x plus y minus z equals 0. And then x plus y plus 2z equals 6. Okay, now notice that this one isn't really nearly as easy to work with on this one because you don't have anything that's going to easily cancel. Nothing really jumps out at you. Okay, But one thing that I do know is that I've got a y here and I've got another y here. So I can use that to my advantage. Let's say I'm going to multiply this equation by -1. Okay? And I can use that to cancel out that y. So if I do that, I'm going to get -x minus y minus 2z equals -6. So that's my new equation. Okay? And I can write this over here because this is what I'm going to work with. 3x plus y minus z equals 0. Okay? And then I can move on and get my marker out. I can move on and solve this thing. What I'm going to do now is I'm going to add these equations together. The y I know is going to immediately go out with the negative y because that's why I did this in the first place. And again, remember, we're only working with these two equations right now. So let's move on to the rest. 3x minus x, I'm going to start to, not really skip steps here, but I'm going to start to accelerate what I'm writing down here. 3x minus x is 2x. Okay? Convince yourself of that, so I'm just going to write the 2x down instead of writing the whole thing down and wasting a lot of space. Minus z minus 2z is -3z. So I just added these two together, -z plus a -2z, -3z, equals 0 plus -6 should give me a -6. Now notice I've taken these two equations and I have reduced them to a form where I have equation in x and z, and I've eliminated y. So ideally what I want to do, now that I've used these two equations, is I want to use any two other equations here to, again, write another equation in terms of x and z, and then I can use it to solve. Okay? So the next thing I'm going to do is I'm going to work with these two equations, and I'm going to multiply this equation by -2. The reason I'm multiplying it by -2 is because I want to make this y, I want to make it -2y so that I can cancel this. Okay? So let's do that. First, I'm going to write down the top equation. I'm just going to write it down again. 2x plus 2y plus 3z equals 10. And then I'm going to write this one down with the multiplication. -2 times 3 is -6x. -2 times y is -2y. -2 times -z is +2z. And then -2 times 0 is just 0. And again, I can add these two together. I know that the 2y is going to cancel with the -2y. That's why I did it in the first place. 2x plus a -6x is -4x. Okay? 2z, or 3z plus 2z is 5z equals 10 plus 0 is 10. I have succeeded in what I tried to do. I eliminated y from this pair of equations to get an equation in x and z. I eliminated y from this pair of equations to get another equation in x and z. Now I have two equations in x and z, and I use those two equations to continue to solve the problem. Okay, so what I'm going to do here to make it clear is I'm going to write this equation. I'm just going to write it again down here so that we know how to move on. 2x minus 3z equals -6. Now I need to solve these two equations. And how I'm going to do that is I'm going to manipulate this so that I can cancel x out. And the reason I pick x is because I've got a 4 and a 2, and I know I can multiply this by 2, and I can help myself. So I'm going to multiply this whole equation by 2, and that's going to give me 4x, which is just going to cancel there. So let's do that, and we'll write it over here. 2 times 2 is 4x. 2 times -3 is -6z equals -6 times 2, -12. Now let's rewrite this equation just to have it above here. -4x plus 5z equals 10. All I did was take this equation and rewrite it right above it so that I had it there. Of course, you might recall the whole point that we did this was to cancel the 4x, which you can see happens with the positive and the negative. 5z, 5z minus 6z is negative 1z equals 10 plus a negative 12 is just going to be a negative 2. Okay, so all I did was add 5z plus a negative 6z gives me negative z. 10 plus a negative 12 gives me negative 2. And then I can just solve for z by dividing by negative 1, and that's just going to give me a positive 2. And this is where I need to go, what I need to have to finish solving the problem. So I've got one of the variables. I can plug it into this equation to get x. Okay, so I'm going to draw me a little arrow up here, and I'm going to plug this in up here. 2x minus 3 times z, but I just found z is equal to 2, equals negative 6. 2x minus 6 equals negative 6. Okay. And then I'm going to move this 6 over here by adding it, adding 6 to both sides. So I've got 2x equals negative 6 plus 6 gives me 0. So then x is just going to be equal to 0 because 0 divided by 2, if I divided both sides by 2, just gives me 0. Now I've got 2 of my variables solved for. And the way you find the third one is you go and you plug it back up into here. You can pick any one of these equations. I'm going to pick the bottom one just because by looking at it, it looks to be the simplest to me. And so that's what I'm going to choose to do. So I'm going to use this one. X is equal to 0, so I'm going to put 0, plus y, which was what I don't know, plus 2 times z, which is 2, equals 6. So y plus 4 equals 6. Y is equal to, and I subtract 4 from both sides, gives me a 2. So x is equal to 0, y is equal to 2, z is equal to 2. If you were going to write that as a point, that would be x is equal to 0, y is equal to 2, z is equal to 2. And that would be the solution. Those are the only problems I'm going to work with the 3 variables and the 3 unknowns, mainly because they get to be an entire board full of stuff. But I think you see the point here. What you need to do is you need to work with 2 of the equations to eliminate a variable, and you arrive at some equation. Then you work with the other 2 equations, and you try to eliminate the very same variable so that you get another equation here that has the same variable missing. Because what you want in the end, in this interim step, is you want 2 equations that have the same variables, x and z. Then you can use the same technique to eliminate one of these variables, which is what we did right here by eliminating x. And then we solve for z. Once we have z, we go back up, find x. Once we have x and z, we can go up here, and then we can find